construction site. Structural engineering is a wider discipline under the field of civil engineering. It is a vast topic, with unlimited theories and practices. It's a field that is still developing with huge innovations and ideas. So, being a structural engineer, the roles and responsibilities that have to be received is of greater importance. In this video, I am going to discuss about the roles and responsibilities of structural design engineers in construction. So, stay tuned. Before moving on, I would like you to subscribe us and press the bell icon so that you never miss an update. A strong knowledge of physics, creative problem solving, and three-dimensional conceptual skill must be gained by a structural engineer. Other than these, the roles and the responsibilities of the structural engineer includes: Number 1. Structural designing. Structural engineers are more graduated in their analysis. So, they are more into design of structures. The structural designing procedures carried out by the structural engineers include calculating the loads and the stresses acting on the building, analysis for the loads, design of sections of structures to sustain the loads so that the structure designed will withstand the loads predicted safely. The structural engineers are also involved in the selection of materials best suited for the structure. The quality factors of different building materials can be analyzed by a structural engineer to finalize their suitability in the design of the beams, columns, or the foundations. Another skill of a structural designer is the analysis of structures. This is presently carried out by the software like ETABS, etc. As years pass, new software are being developed for the analysis of structures at different conditions of loads, like wind, earthquake, etc. Most of the structural engineers have to study and work with these software with the knowledge of both the technical details and the programming details. In some organizations, the analysis is carried out by a programmer who may not have the civil engineering graduation, but is assisted by a structural engineer. Whatever be the mode of analysis done, the structural engineer must have the ability to understand and interpret the results from the software to know the validity of the values provided as output. Some organization won't completely rely on the computer results. They conduct a separate, man-made calculation for assurance. Number 2. Site investigations. When dealing with the site investigation, the structural engineers are involved in checking the condition of the soil for the construction of the project. Based on the loads calculated by the designer, it must be checked whether the soil is suitable to bear the calculated loads. This investigation will also decide the foundation systems that must be used for the structure. Any kind of treatment required for the soil, too, is decided based on the investigation. This investigation is carried out by testing the soil, which is the part of geotechnical engineer. Number 3. Communication. Even though structural engineers are the ones that bring and develop the design ideas and detail, he can only see it happen on the site only if the structure is constructed as desired. For this, his interpretation and ideas have to be conveyed with the other members of the projects. The structural engineer has to coordinate and consult other members, like the site engineers, other design engineers, geotechnical engineers, landscape architects, project managers, etc. Proper communication helps in spreading correct information among the group, avoiding confusion and errors. Number 4. Construction management. The management responsibility of a structural engineer starts from the collection of sufficient information for the project to the execution of different activities on the construction site. In certain critical situations, they are responsible for material and equipment delivery, for undergoing a special task of the construction project. They conduct frequent checks on site, labor works and activities. That's all for today. See you in the next video. Thanks for watching this video.
Good afternoon to everyone. I switched off. One minute. So good afternoon, everyone.
Good afternoon, sir.
So I have gone through your corrections. So last half an hour, I'll talk about your marks and the performance that you have done for the first internal exam for the lab. We'll discuss later. But now we are going to discuss about the designing procedure for an RCC building, which is the pending part for our syllabus. As per the syllabus, the design part is left behind. So that I would like to share the video regarding that one, and I hope everyone will follow this video carefully to understand how to design the entire building. So far we have discussed about how to apply the loads and how to analyze and find out the bending moment, shear forces, deflections, and mode shapes. Everything we have discussed. Now, after applying all the loads and the geometry is perfectly ready, there is no errors in the model, and the final and step in the design of any structure is designing itself. So this is the final step, and after this, one more step will be there. That is nothing but the report part. The report part is something that the third person has to understand that will be in two formats. One is the drawing format and other one is the calculation format. So the calculation format, the software is going to give you the calculation format, and drawing format you have to again go to other softwares. However, this software will help you to certain extent, but not completely. It will guide you to certain up to certain levels, but you have to again adjust all the drawings, and you have to correct them and make sure that it can be understood by the non-technical engineers also. Okay, that is the third person, like the site engineers or the planning engineers or the construction engineers, or the client, maybe someone who is from the other departments who wants this structure to be constructed. Then in such cases, they should understand the drawings. So you have to develop those drawings. That is the next step after the design part. So as far as the structural engineer, this is the role that you have to complete the design, make sure that all the members have passed, and if any modifications are there or required by the architect or by the design failure, if there is any design failing, then you have to recorrect that and redesign the structure, and then you can complete the model and give it for the drafting purpose. So drafting level, you have other technical engineers, they are going to assist for the drafting. Okay, so today we'll discuss about the design part. So everyone follow this video carefully. So this is the video which we have discussed long back for the high-rise building. The patterns of loadings and everything has been completed. Now how to design the structure is the 17th step. That is what we are going to discuss now.
The structure for concrete and shear wall. So we go to display and undeformed shape. After that, we need to go to design, concrete frame design, and view revise preference. Here we need to enter the design code as IS 456-2000, although various other options are available. After that, number of interaction curves, number of interaction point, consider minimum eccentricity as yes, consider additional moment as yes, no. Design for beam, consider P delta done, we need to click it as yes. And design for beam column capacity ratio, gamma steel 1.15, gamma concrete 1.5, pattern live load factor, that is the live load factor for automatic generation of load combination involving pattern live loads and dead loads, and utilization factor limit as 1. So here we have changed this consider P delta done as yes, so that is why it is showing as red, otherwise all the default options are coming as blue. So left click on OK. After that, rebar selection rules for columns. So here we can set it as smallest bar size is 16, largest bar diameter is 32, ties smallest bar size is 10, largest bar size is 16, minimum spacing is 50 mm, maximum spacing is 450, and detailing for seismic requirements. We can done it as smallest bar size is 16 and largest bar size is 32 again, and similarly for this. Left click on OK. After that, rebar selection rules for beams. The longitudinal bar size and quantities for non-seismic and seismic requirements, and similarly we can select the stirrup bar sizes and spacings, and left click again on OK. And after that, select design groups, combination, start design check. So design group is not an important option right now, but select design combinations is an important option. So now what we need to design first, let us say we need to design columns only. So for columns, our load combinations are, so for foundation and column strength design, we need to select 101 to 137. For foundation column strength design, for orthogonal buildings, we need to select it as from 101 to 137, as thermal loads and fire tender loads are not there. So we select all the load combination from 101 to 137, left click here. So now the design combinations are selected here, so left click on OK. And after that, design concrete frame design and start design check. You can notice that although we need to design columns only for those load combinations, but the software is designing the whole structure for that load combinations. So what we need to do is that we need to design it in two different manners, that is from 101 to 137 and from 201 to 237 load combinations. From 101 to 137 for column design, and for 201 to 237 for beam design, and from 301 to 337 for service load design. That is when we need to check the deflections and when we need to check the creep and shrinkage. As it is taking a lot of time, what we can do here is just left click to cancel, and then select object type and select columns only. So left click on select and then close. Go to view and show selected objects only. Select all the columns, go to design, concrete frame design, and then start design and check. So with this manner, the software will design only the columns. So we can see here that the color of all the columns is magenta only, and here you will see some numbers here. So this is the reinforcement area that is required. So let us say if we go to this column, left click here and then again right click. So here you will see that the column size is 750 into 900, and the longitudinal reinforcement that is coming here is approximately 5400 mm square. So what we can do here is that we can go to details, and here you will see that in every column the software has done the design as per the Indian standards. So here you will see that for this basement 1, the element is named as C6, unique name is 85, and the design combination that is governing its design is 0.9 dead load plus 1.5 wind load, and the location is that is at the bottom. The length of this column is 5100 mm. So here you can see that the axial force, that is design PU, is approximately 2222 kN, and moments are 74, 85, and the rebar area that is coming is 5400, and the percentage is 0.8 percentage only. That is the minimum percentage of reinforcement. So if we want to check the flexural details, we can see here. After that we can see the shear details also, joint shear details, beam column capacity ratio details, and the envelope forces. If we want to export this report to Word, so we can left
Whatever is shown over here is all the standards that we have to go through IS 456. You see from here, this concrete, whatever diagram is there, for every column, if you click on the member, the report will come like this, and you can see these are unique names, and elements are the software that has given the names, and this section ID that you have given 750 by 900. That is M50 grade of concrete, and the load combination is governed. So out of all the 100 loads or 200 loads, whatever combinations that were what you call created, out of that, this is the critical combination. It is showing out of all the combinations, and the length of the column is 5.1 meters, and the other value section properties are here. Then the standard EC value, that is EC is 35355.34. How did you get that? FCK grade of concrete is M50, and FI steel is 500. Grade of steel is 500 is taken. Then design code parameters as per limit state design. For concrete, it is gamma C is 1.5 and gamma steel is 1.15. So here the reliability on the concrete is less when compared to steel. That is, we are taking the factor of safety for the steel as 1.15. That is almost, we are taking only the 15% extra. If you say that we have, if the strength of the column or the strength of the steel rod is capable of carrying 100 tons, that means that we are considering only 85 tons capacity. But when you talk about concrete, it is 1.5, that is 50%. If really the strength of the concrete is 100, we are only considering 50 of that. That is the meaning. The factor of safety means to what extent you can consider the material strength. Then after that, you have these values, that is additional moment reduction factor K. These are calculated as per the code, and additional moments as per IS 456 39.7.1 clause. These are the values.
document. So left click on OK. Similarly, we can check
column,
for any other
click on
column.
the column, you will get the details.
So we go to details, and then we can check all the appropriate data. And after that, if we want to check the interaction, so we can see the interaction also for a column. So current interaction curve is like this, and we can also
This interaction curve is for the P and the moment. Axial load is on y-axis and moment is on x-axis. This is the interaction curve through which the moment is increasing as the load is increasing. And as the moment is reducing, the capacity of the column to carry the axial load is increasing.
Change the view of this, like we can check it in 3D, mm, pm3, pm2, and we can also we can show include material strength reduction, exclude material strength reduction, and show fiber model data. So by default it is show design code data including material strength reduction. So all the curves has separate data, that is for curve number 1 0 degree, curve number 2 15 degree, curve number 3 30 degree, curve number 4 45 degree. Similarly we go up to curve number 24, that is for 345 degree. And we can also check the overrides here, that is the current design section is varies, framing type is ductile, live reduction factor is 0.6, and similarly we can consider minimum eccentricity, it is selected as yes, effective length factor varies, so let's click on OK. So for each and every column it has provided a comprehensive data for all the details and all the design data. Similarly, if we want to check some other parameters, so we can go to design concrete frame design and display design info. Here we can, right now it is longitudinal reinforcement option is selected. We can go to rebar percentage, left click and apply. So here you can see that the minimum reinforcement is coming on all the columns. After
so here in this table over here, display concrete frame design results, where you can display the results in the form of percentage of steel as well as longitudinal reinforcement. First, initially it was longitudinal reinforcement, that is for every column of height, 1 floor height, the column reinforcement will be given. According to that, the number of bars you can choose. For example, if you are getting a column reinforcement as for example, if you're getting column reinforcement for one column as 3000 mm square. So for this, how do you provide the reinforcement? How do you provide the reinforcement? So you have to assume some reinforcement of steel, like for a column. Let us say the column size is somewhat a rectangle, which is 500 into or 230 into 500 as the column size. This you can take the standard size that for apartments that are regularly modeled are 230 into 450 is the column size. For this one, you have the column size that is given over there. Reinforcement that should be accommodated as per the software is 3000 mm square. So if it is 3000 mm square, what are the rods that you should provide? This 3000 mm square. So what are the rods? How many rods you have to provide? And what is the dia of the rod? So that it will reach 3000 mm square. So can you tell? Huh? That's what I'm saying. You have to assume the diameter of the rod. Like how much you will assume? Minimum steel, it is for 3000. Software will automatically give, if it is coming lesser than the minimum steel, software will give the minimum steel. So 3000 is required. If you provide more, that means if you have money, you can provide. If you want to provide 5000 mm square, obviously it will cost more. So you should reach 3000. That is the requirement as per the design. If you keep more, it is up to you. So 3000 means what is the dia of the rod? So what is that is a question mark. So there's generally standard, they'll go for area of steel is that is the minimum steel. 1% kuda this. First of all, minimum steel is a condition where if the loads are lesser than where the steel is not required, మీకు లోడ్ అంత లేదు, లేనప్పుడు మీకు మినిమం స్టీల్ గవర్న్ అవుతుంది. సో the software will automatically take it into consideration. The minimum steel is the condition which automatically by default, if the load is only 10 kilonewton on the column and your column is such a big column, then no need of steel, right? Then no need of steel. But as per the code, the software will calculate. It will assume 0.8% and then automatically for that 0.8%, it will calculate the area of steel. For example, you're talking about 415 to 230 column size I'm talking. So 415 to 230, in that 8%, 0.8%. So how much you are going to get, that the software is going to give. That you can provide. So now my question is not that. So how do you calculate the dia of the rods? That is my question for 3000. అదే నేను అదే కదా క్వశ్చన్, నా స్క్రీన్ చూస్తే నీకు అదే క్వశ్చన్. 3000 mm square is the area that software is given. Now my question is how many rods you provide and what is the dia of the rod. So for that, what you should do? 25 mm dia rods. So first you should start with 25 mm dia rods and minimum 10 is there, but 12 for columns is preferable. For beams, you can go with 10 or 12, but 12 is suggestible. 10 dia rods and 8 dia rods maximum we'll be using for stirrups. We will not maximum use it for load carrying purpose, but only to bind the main columns, main rods, we are going to use 10 dia and 8 dia as binding materials. But preferably 12 is better. Maximum go with the 12 dia rods. For stirrups, 8 or 10 that we can do. 6 is out of question nowadays. 6 you can use it for lean concrete, even structure, non-structural members like retaining walls, not even retaining walls. In retaining walls also you have to use 8 mm, but which is if it does not has any impact, if it is going to fall, if there is no impact, in such cases you can use 6 day. Steps is very important. Steps are very important. We mottham design loni steps, staircase is very important. Staircase design vaste 60% you are almost done with the understanding of the drawings, because staircase the complicated. When you do it, you will understand where the landing will come, where the flight will come. That is different. We'll discuss about that later. But now what is the dia you are going? As he said that one of the student over here is talking about 25 mm dia rods. So 25 mm, you calculate the area of one dia of 25 mm rod. So please calculate what is the dia area of one rod of 25 mm. That is what we used to do in RCC, right? RCC law. I'm not asking any new question. So pi by 4 into d square. So how much you are going to get? 491. So I can say that I'll write over here. So if I use 25 dia rods, then the area rod is 1 rod is how much? 491 వచ్చిందా? Approximately 491 mm square. That is the area you are talking. How many rods you have to provide? Like 3000 divided by, then you have to provide 3000 divided by 491. So how many rods you are going to get? 6.1. You cannot provide 6.1, and 7 also you cannot provide because it's an odd number. So to arrange it, it will be difficult. So what you have to do, you have to either use 8 rods or 8 rods. If you use 8 rods, you can accommodate over here. You can accommodate 1 rod over here, 1 rod over here, then 1 rod over here, 1 rod over here, 4, 5, 6, 7, and 8. Okay. So 8 rods you provide. So the required is 3000. The required is 3000, and you are providing how much you're providing, then you have to recalculate again. That is 491 into 8. How much you're going to get? 491 into 8. 3928 mm square. So the required is 3000 and you're providing 3900. So almost 1000 mm square you have increased. Okay. So that's good. Next, what you have to do? 25 dia rods. If you use 8, it is becoming higher. So you can give the combination. What is the combination? 25 dia rods, you use 4, and 20 dia rods, you use 4. Then find out how much you are going to get. So this is I can say that trial 1. You can say that this is trial 1 is this case. Trial 2 over here. What I'm going to do, I'm going to use 4 numbers of 4 of 25 dia, comma, I'm going to use, and another 4 20 dia rods. That combination also you can give. So if you do like that, you can minimize it, because the required over here is 3000 only, but we are giving 3900, almost 1000 mm square you are increasing. So it is waste of money, and it is not economic, because for a high-rise building, you can imagine that for 30 floors and 40 floors, it is not suggestible. Even for residential buildings of G+5 and G+4, there also it is very uneconomical. Yesterday, day before yesterday, one client came. He is saying that he wants to reduce the steel as much as possible. So they don't understand. The builders will always talk about money, but the importance of the columns they will not recognize, because the columns are the main important structural material. If you don't provide the columns, they say that reduce the columns, number of columns. We can reduce anything, but columns cannot be reduced. They say that we want as much less columns as possible. So that is what the clients will come like that. Different clients. Some clients will come and say that no, don't compromise the columns, because they know the importance of the columns. Some are like that, but one client is there, he wants to reduce the columns. So what happens is that project, you can take it as a project also. You design the entire building, one building for 30 columns or 40 columns, and you design the same building with 28 columns or 25 columns. The same quantity will come. The same thing will come. Where you're using 40 columns, you will reduce the size of the steel. You will reduce it to 12 dia rods. Over here, if you use 28 columns, what happens? The additional load you have to again distribute it over here. So obviously you will use 25 dia rods. So obviously the cost will be the same. This the client will not understand. Finally, he is spending the same cost. He's spending the same cost, but he will feel very happy that we have reduced from 30 columns to I have reduced to 25 columns. That is how they feel it. But internally, as structural engineers, we know that it cannot be compromised. That also is different. Now, recently, the steel cost has increased from 50,000 for 1 ton. It is 50,000. Now it is around 70,000. 20,000 it increased. It is drastic change. I think last time when I heard is 2 weeks back, 3 weeks back, I heard it is 64,000 something for 1 ton. So obviously it is very high, drastic change. Okay. So what happens is that has to be balanced. Sometimes what we do is that since the steel cost is more, what we have done, we increase the column sizes, like footing sizes, and reduce the dia of the rods. That interpolation we can manage as structural engineers. So that is small things we can do, but not like completely avoiding the columns. Okay. So that is a different story. We will come back to that later. But now tell me how much is the area that you are going to get if you are using 425 dia rods and 420 dia rods. So what is the area of 20 dia rod for 314? So for 25, so 20 dia rod, you're going to get area of one rod as one rod is 314 mm square. Now the combination of this one, so you have to multiply 4 into 491 plus just a second. So here I can say that 4 into 491 plus 4 into 314. How much here it is coming up to? 3221 mm square. It is a little bit closer, right? So you can select this option is better than the previous one, where you have reduced the quantity of steel at the same time you are reaching the minimum requirement of steel as 3000. Okay, but still you can reduce it to 3000 because you can still reduce 200 mm, not a problem. As an experience things that we go on, because as a beginners you can give this one, but you can reduce it 3000 because already the factor of safety is 1.5 times. We are already implementing 1.5 times. So neck to neck, whatever reinforcement the software is giving, you can go with that one. Okay, so that is how it is going to be there. So here the ETAP software has it can give the it is going to give in the form of percentage of longitudinal reinforcement as well as rebar percentage. You can see that second option is rebar percentage, where it is going to give in percentage. Okay, then you have shear reinforcement, column PM interaction ratio. All these things are for advanced kind of approaches. If you want any additional information, then all the things are available. Since it is a software, only that we have to give the command, it is going to execute. But if you want to do it manually, if you want the percentage of all the columns and all, it's not possible. I mean, it's going to take a lot of time.
That shear reinforcing. Now the shear reinforcing data is now visible here. After that, column PM interaction ratios and beam column capacity ratios, column beam capacity ratios. So if some column is failing, we can either increase the size of that column to check that to make the structure safe, and then after that we can left click on close. Besides that, there are various other options. That is, for example, we can verify analysis versus design section, verify all members passed, or delete the design results. So now we should change our focus from columns to the beams. That is, we go to view and we left click on show all objects. We go to display undeformed shape. After that, we need to go to select and then object type. Select the beams here, left click on close, go to view and selected objects only. Go to design concrete frame design and select design combinations. So now we should change our combinations from 201 to 237. Left click on OK. Select all the beams here, go to design concrete frame design.
So those combinations that are there are given for the beam design. So for the column design, one set of combinations are there, and for beam design, one set of combinations are there. Since it is an high-rise building and it is a complicated structure, you are having so many load combinations. But for low-rise buildings like G+5 and apartments or any industrial building, if there is no earthquake forces, then only we can directly take for the design as 1.5 times of dead load plus live load. That is more than enough. But if you have earthquake zone, if it is coming under zone 3 or zone 4 and zone 5, zone 2 it is also negligible, but zone 3 and 4 it is dangerous. And one more thing is that for which type of structures you are going to have impact of the earthquake load. Just a second. Actually, initially, I think online students doesn't know that what is happening over here. Few workers are coming over here and disturbing our class. That's why I'm just pausing. Initially, our department was not here. Just few months back, like in December 2029, just a couple of days back, the department has been shifted to this Cotton Bhavan. So that's why there is a lot of correction going on. Anyway, so the beam ratio, like beam combinations, the beam, those are the combinations that have been used. And one question to everyone is that for what type of structures earthquake is more effective? Earthquake is more effective. If I take for a particular region, like let us take both the structures, I'm taking two structures, both the structures are at the same place. In zone 4, let us say the buildings are affected to zone 4. Zone 5 is very critical. So zone 4 means somewhat critical. So I am taking two structures. One is the high-rise building that we have modeled, and another one is the building with low height, which is more effective. Huh? Low, high, which one? So it depends upon the weight of the structure. The effect of the earthquake depends upon the weight of the structure. Even though if the height is more and the weight of the structure which is having less height will be affected more. So lightweight structures will be affected with the more earthquake impact. Okay. Even though if it is high, the structure is high, when compared to the structure which is having low height but lesser in weight, that structure will be affected. You have is VB into base shear, VB into W into VB. No, base shear equals to W into that formula is there. No, what is that? Base shear W into force coefficient. W into coefficient is there. Earthquake coefficient is there. AH. Yes. So W is what weight of the structure. Based on the weight, the base shear will have more impact. If the weight, it depends upon that. Okay. So when we design these towers are there. These towers are there surrounding the city. Those towers will be affected more due to sorry, I told reverse. Actually, the weight, as the weight increases, the impact will be more. If the weight is less, then it is not effective. That is what. So W into AH, base shear equals to W into AH. If the weight is more, then base shear will be more. Okay. I'll just show you one small example over here. So if this is the structure, is it visible? If this is the structure, the base shear VB equals to W into AH. This is the formula. W into AH of Q
design and start design check. So now ETABS has done the design of all the beams. Here you can see that the lot of the beams are showing as red color. So all these beams are basically failed. That is, for example, these beams are failed in the shear. So to make the things easy, we can go to a particular plan. Let us say that we go to 17th floor and then left click on apply and OK. So what we are saying here is that we can see these 6 numbers. So on the top, basically 1169 mm square reinforcement is required. In the middle, 486 mm square reinforcement is required, and here 867 mm square reinforcement is required. So if you will just hover your mouse over this beam, it is showing that the eye and top reinforcement is 1169, eye and bottom reinforcement is 971, which can be seen from the yellow colored box also, or whatever it is written on.
So now you can see the beam detailing, beam reinforcement, whatever is there. You can see that it is given for one particular span, or with for one particular grid, the beam reinforcement is given. And can you notice something from this detailing, whatever the reinforcement that software is given? Did you notice any anything? Did you notice that is what you can observe? Any observation is there from these values? You watch carefully. Is there what is that? Is there bottom reinforcement is equal? Yeah, that is one point. Now bottom reinforcement is not equal. No, for the longitudinal direction, the bottom reinforcement is different. You see there. For the other direction, the bottom reinforcement is different. But for the horizontal direction, the reinforcement is same for the bottom. That is okay. Any other observation? Yes, exactly. That is the important point in beam designing. See, at the ends, the reinforcement is more, and at the center, the reinforcement is less. So that is an important point. You can see on the left hand side and right hand side, the values are more, and the bottom, the middle values are less. Okay, and in this diagram, you can see that that line, whatever the beam is there, the values that are given top of the line, they are called as top reinforcement, and the values which are given at the bottom are called as bottom reinforcement. Okay, so why is this difference like that? Why these beams at the ends the reinforcement is more, and at the middle the reinforcement is less?
Columns. I mean,
Yes,
distribute
someone is talking.
load distribute just can tell us.
లోడ్ డిస్ట్రిబ్యూషన్ అంటే లోడ్ ఎడ్జెస్ లో ఎక్కువ డిస్ట్రిబ్యూట్ అవుతుందా?
కాలమ్ కి ఐ మీన్ కాలమ్ కి డిస్ట్రిబ్యూట్ అవుతున్నప్పుడు అంటే కాలమ్స్ అక్కడ ఇప్పుడు ఈ పాయింట్స్ లో చూస్తే కాలమ్స్ అక్కడే కదా సార్ ప్లేస్ చేసేది మనం, అక్కడికి లోడ్ డిస్ట్రిబ్యూట్ అవుతుందేమో.
సో ది మెయిన్ పాయింట్ ఆఫ్ హియర్ ఇస్ if you go to the analysis, structure analysis, if you take a fixed beam, what is the, with UDL loading, what is the formula?
Moment sir.
So if I take a beam, if I take a fixed beam, if I take a beam like this, and this is my beam, and this is fixed at one end, and it is fixed at other end, and you are having a uniformly distributed load throughout. What is the formula for this one? what is the formula for this uniformly distributed load beam? Fixed end
WL square
moments.
by H.
WL square by
8.
WL square by 8.
12.
8 or 12?
12, sir. Fixed end moments WL square by 12. Sir.
UDL అయితే 12, point load అయితే 8.
Sir, 8, sir.
So you're getting little bit confused. Be careful. You are saying that WL square by 12 and WL square by 8. So out of that, which one is correct?
12, sir. WL square by 12.
WL square by 12. Okay. So when WL square by 8 will come then? And you are saying WL square by 12, right? And let us take these two out. WL square by 12 is 1. And this side also same. WL square over here also you are going to get the same value at the end. What about at the center? WL square by 8. Anyone from online students? What is the value at the center? Bending moment value at the center. Bending moment value at the center. You have a clue also. You have a clue that the diagram, whatever is shown of here in this diagram, at the center, this value is less, right? When compared to the external value, then what is the value at this center? So it is WL square by 24. Half the end value. So that is the value WL square by 24. Next knee దగ్గరికి వస్తున్నాం. Okay, this is the value for fixed beam. Now for simply supported beam. Now when you have a simply supported beam over here and it is supported at this point and at this point. For this with uniformly distributed load, the bending moment formula here is what? WL square by 8. If you have uniformly distributed load over here, then the value over here is 8. And that also where it is going to come at the center, not at the ends. At the ends for simply supported beam, the moment is 0. So here it is going to be WL square by 8. WL square by 8. Okay. So these are the formulas. So the bending moment diagram for this, how it is going to be for fixed beam. The bending moment diagram is going to come like this. It is going to come somewhat sorry, so increase a little bit more. This it will be there, and the bending moment diagram is going to come somewhat like this. Okay, so at the ends the moment is more. For fixed beams at the ends the moments will be more. That is the answer. For fixed, as you told, it is right on. So here, for the fixed beams, the moments at the end will be more, and at the center it will be less because of this formula and this formula. You can cross check also if you want. So here, if it is 1000 at the end, if it is 1000 or 100 kilonewton meter, how here it is going to be only 50. And again here it is going to be somewhat 100. Small changes might be there, like in the real structures, like for this example, in this one, small changes will be there. Here, this beam, you can see that 1804 is there, 1790 is there. So some changes will be there. So this is the reinforcement at the in the beams. Sir, now how do you provide the reinforcement now for the beams? How do you provide the reinforcement? Now it is given over here for this particular beam. Let us take this beam as the second beam. I am taking the second beam. You can see my cursor moving. This beam at the end it is 1560 and 1059 at this end and 486 at the center. So how do you provide the beam reinforcement? How do you provide the beam reinforcement? How do you provide the beam reinforcement? So here at the center, what is the reinforcement you are having? 486. That is, it should reach, you provide bars such that 486 will first, you can reach. So here, what I'll do is that, this is my online lo cheptunna kada, I will use my mobile so that I can flexibly use this to a better extent. But then I don't have the Wi-Fi connection. Staff connected. Yeah, connected. Yeah, I can use. So here, this is my span. This is my cross section, right? And this is my beam. వస్తుందా వస్తుంది కదా you are getting now. So this is my beam and there is a continuation over here. This one. Now the reinforcement is given as per the drawing. The reinforcement is given as at the top 1590, at the center 486, and at the end it is 1059, and the beam is still continuing over here this side. If I remove this one, the beam is actually continuing over here. This is one span and from here it is still continuing like this. So here what happens, this is the end. Let us take this is the end over here. So here you are getting 1590, 486 and 1059, and at the bottom it is 971, 971 and 971. So in beams maximum they are going to use 1 dia rods and 16 dia rods, and if the load is very high then you go to 20 dia rods. If you go to 25 dia rods, then the beam must be big or heavy beam, or it should be like 500 mm depth or 400 600 or 700, more than 450 it is better. Then you can go with the 25 dia rods. But if it is 450 mm beams or 500 beams, below 500 it is better to restrict the beam diameters to less than 20 dia. Okay, so now my reinforcement is 486. So you calculate now 12 dia rods, what is the area of one rod? 113. For 16 dia rods, This is mm square. 201 mm square. And 20 dia rods 314. We have calculated this just before only. So these are the areas for one rods. Now you are getting 416. You are getting. That means how many rods of 16 dia you can use to get 416? You can use 2. 2 is not sufficient because you are going to get 400 only. 400. 486 cannot be reached. Then what you do? 12 dia rods if you use, you have to use how many? 4 rods. 12 dia rods at the top you have to use 4 rods. Then you are going to reach 452. 452, that is acceptable. It is very close, less than 1%. Or else you can take 2 16 and 1 12 dia. That is better. 216 you are going to get 216 you are going to get 400, and 112 you are going to get 100. So it is going total, it is going to be 500, right? So if I draw the cross section of here, this is my cross section of here, the beam. Now I'm using 216 at the top. This is 116, another 16, and 12 dia at the center, such that I'm going to reach this 416 first. I have reached 416 first, right? Now you deduct still you have to but at the end you have to reach 1590. 1590. Then what should be the rod? Already you have, how much you have provided already? Already 405. This is total, this area is 515. Okay, 515. I am writing it over here, somewhere over here. 515. Okay, 515 already we reached. So if you deduct that, almost 1100 is still behind. We are still 1100. We have to provide 1100. So 1100 means you have to provide 420. You have to provide 420. 420 is how much? 4 3 is 12. That is 1200. Right? So that means you have to provide 4 extra rods of here of 20 dia. 1, 2, 3, 4 extra rods of 20 dia to some extent, like this. In the this is your main rod. It is going to come like this and continue. Of here, 4 extra rods will be there, which can be seen in the cross section. This is my cross section. This is my cross section, right? In this cross section, you can see the rods arranged over here. So these are my extra rods over here, right? Now this side it is 1059. So 1059 means how many? Already we have provided 500. Still 500 should be provided. That means this side you can provide 220. You can provide 220 extra rods. And at the bottom it is 1000, almost 971. That is equal at 3 ends. So you can use 320. 320 means 900, right? Okay. You can use 320 at the bottom like this, or 220 plus 216. 220 is 600 and 220 is 400. That also you can do. So at the bottom, I will provide here 220, and then I'm going to use 216. This is called the beam, this is how every beam should be detailed in this manner. Okay, every beam should be detailed in this manner. Then if you come to the next beam, you can again find out the reinforcement over there, and the bar should continue on like this. This bar should continue in the next beam, and they should go on based on the reinforcement at the junction. That is the beam detailing. That is beam detailing that have to be done. The software will give you the areas, but it does not select the reinforcement properly. It will not. It will do it to some extent, but the remaining part we have to do. So what I can say that I can openly say that if you can work on this one and develop a software where whatever you are now fixing it manually, you can program in it. If you can program that one and you can show to the world that I have programmed it. అంటే మీకు సాఫ్ట్వేర్ లో ఆల్రెడీ ఇది ఉంది 1500 400 ఏరియాస్ ఉన్నాయి దానికి స్టీల్ రెయిన్ఫోర్స్మెంట్ ఇప్పటికి వచ్చి any of the softwares are not accurately doing it. To some extent they are doing it, but not accurately doing it. So you can create a program in such a way that the reinforcement can be selected by the software. Like that, research work will go on. Now at the higher levels, at not lower level, this research work will be going on. And the software, the technical developers also are continuously doing this exercise actually. They are actually doing it. I don't know when it's going to come into existence. Maybe when you, after 5 to 10 years, this also can be taken up. Now they are talking about artificial intelligence in civil engineering. And also they are talking about Python programming in civil engineering. So all these are coming up. So the CSE and civil is going to be clubbed. So you to benefit the technology, to explore to these kind of technologies, it is going on. The research is going on, and lot of things are there to learn. And you can, if you can do that programming, you can become a billionaire just like in WhatsApp. How they are, it is not. It feels like a joke, but it is true. It is really true that some few years back, when being a faculty, when we are using WhatsApp, we were not encouraged to use WhatsApp in colleges by the faculty members, by the department heads and all. We are not supposed to use phones and all. Now what we are doing, obviously in this lockdown, we are using WhatsApp as the main criteria. Before we used to send mails. That used to be the communication. That used to be the official communication. Now WhatsApp is official communication. WhatsApp is official communication. They send any mail, any message, it is official now. Officially you have to do that. So the trend will automatically change day by day. They used to make fun by this WhatsApp. There people are unnecessarily wasting time. Especially the youth is getting spoiled with this one. So one phase that also is there. If you use properly, the advantage also is there. So that is what that gap is there. Really, I'm saying this gap is there in industry, that if you can learn any nice programming like Python or so many softwares are there. If you can learn and create a program or algorithm where the reinforcement can be calculated by the software and provide the reinforcement, then you will become a billionaire. Sure, that how we can implement and all, that is different. But this is what I can say. Like this, in structures I am talking like this. In software I'm talking, not in structures. In software, this is the drawback. In any kind of a subject like theory of elasticity is what I am saying. In that also a lot of research can be carried out. Then you go to the foundation engineering, lot of research can be carried out. If you go to transportation, lot of research. So every engineering stream has the next level. The next level is always there, and so many question marks are there still. The what you call the professors, even IIT professors and what you call the university professors everywhere throughout the world are still having question marks. What is the solution for these problems? So everywhere there is a challenge and you can implement it. Okay. Again, I'm going somewhere else. So come back to the subject. Now we have done this beam detailing. This is how you have to carry the beam detailing. You have to, now I have to actually share the screen. Going back to this screen. Now this is the screen. Now this is the reinforcement that we have, and based on this reinforcement, you have to provide the steel detailing, and that detailing will be converted as using the AutoCAD software. You can create the detail. Okay, so we'll continue with this.
On the screen also. So accordingly we can do the detailing. For example, here you can see that 1169 mm square reinforcement is required. So we can provide 4 number of 20 dia bars. Basically 20 dia bar has a area of,
that is what they are saying,
314 mm square. That is how I had calculated this. That is pi 3.14 diameter of bar 20 dia. The 20 square is basically approx 400, and that we can divide by 4. So it comes out around 314 mm square. And if we are providing 4 number of 20 diameter bars, so what we can do, we can multiply it by 4, and here we can provide 1256 mm square, or somewhat greater than 1169 mm square reinforcement. And similarly, if we are talking about the bottom face, what we can do here is that we can provide 314 into 3. That is somewhat less as compared to the required reinforcement, so we can provide 220 dia bars, that is 2 into 314, basically 628 plus 400, that is 216 dia bars area. So we can provide 1028. So we can provide 216 plus 220 dia bars on the bottom face, and 420 dia bars, reducing it to 220 dia bars on the middle face, and then again 420 dia bars on the right side face. So we have an option to provide somewhat higher area as compared to the required. So this detailing part we can discuss further in the next lecture, but right now I want to make it clear that how the reinforcement is being shown here. For example, here you can see that very high reinforcement is coming because this is the main beam that is going from this end to this end. So what we can do here is that we need to provide 4088 mm square on this face and 3719 mm square on this face. Similarly here. So we can start from the bottommost level, basement 2 level. Here all the beams are passing. Here again all the beams are passing. Here you can see that some of the beams are failing in the shear. So basically, if this hash is coming here or on top or bottom, it means that the beam is failing the flexural. But if the hash is coming here, it means that the beam is failing in the shear. And here you can see that the beams is failing in almost all the load combinations. So here you can see that the shear stress due to shear force and torsion together exceeds the maximum allowed. So we need to increase the size of this beam. And here you can see this particular pattern that all the beams, this 1, 2, 3 and 4 beams are failing on all the floors. So we need to increase the size of the beams. Only those beams that are failing in the shear. So here you can see that the software is identifying that whether all the beams are failing in the flexure or shear. Here you can see that V is coming. So these beams are failing in the shear only. So what we can do here is that we need to increase the size of these beams or increase the depth of these beams. So before that, what we can do here is that we can go to Control Shift and A on your keyboard to display all the structure. So basically, as we have done various permutation and combination in the analysis also, similarly we need to do various permutation combination for the design also.
So that is about the designing of columns and beams. Then you have design of shear wall. And many designs are there. Then you have also have slab design is there. As I told you that there is an open kind of an approach where you can create a program to this detailing. The slab detailing is also not performed by any of the softwares that are there, which we are using, especially with the STAAD and the ETABS. It only gives the stress values in the slab, and those stress values, based on the stress values, we can have to give the reinforcement. But manually, many of the engineers and the technical engineers, they are going to use the split sheet, the Excel sheets they are going to use to calculate the reinforcement. Okay, so that is the approach they are normally going to go through to complete the detailing part. Okay, so with this, I'm going to stop the class over here. And now, if you have any questions regarding this designing procedure, you can go ahead and ask. This Irish building, if you have any kind of questions, you can ask. So whatever building you have modeled so far, and whatever approach you have come up with, different types of loadings, dead loads, live loads, and earthquake and wind loads. Apply all the loads and go with the design. It is just only few steps in designing. It is only few steps. It is not at all difficult. It is like only having number of buttons over there available, like a switchboard or some kind of an video game. You can just go there, select the code book, then you can select the load combinations, and then go for analysis, design check. Those are only steps will be there anywhere. This is a constant procedure. Up to analysis, the modeling and application of loads are different. It depends upon type of structure, and depending upon the size of the structure, you have to create the geometry. That will vary. And based on the walls, what is the location of walls, room sizes and all, the loadings will change. Those two things will change, but a design procedure is constant. You just have to go to the design option over here, which is available, and then select the design parameters as per the Indian Standard Code, IS 456 you select, and then you can select the load combinations that are required for designing of columns and beams, and then you can go with the design procedure. So this is quite easy, the design procedure, but it is only how to provide the reinforcement, as I explained you, for the columns and the beams, how you have to provide the reinforcement. That is the challenge that you will be facing. But design using software, it is easy. Any software, you have only just 2 to 3 steps. You can go there and do the exercise. Okay. So far, whatever we have learned in this class, the model which you have completed, I think in the previous class, RCC structures, whatever structure you have completed, to that structure, how to design it, you can apply the concept, and you can show the reinforcement details in terms of percentage and in terms of area. You can take the pictures of that, and you can upload in the assignment. I'm going to give the assignment, that analysis and design of a structure. In that design of RCC structure, I'm going to create one assignment. There you have to take any structure, not only the structure that is there, high-rise building or anything. You can take any kind of structure, design it, and provide the sheets, screenshots, as you have performed in the mid exams like that. You can take the screenshot and upload it. Okay, so that is what I wanted to say for today. And now in the coming to your marks that I have given for the mid one. I don't know how many of you have done it on your own, but to some extent it is okay. I have gone through all your I have gone through all your materials that you have uploaded in GLearn, that unit exam. To some one or two students have copied. I can make it out easily, and one or two students, I think 4 or 3 students are not performing well, but remaining students, it is okay. You are up to certain extent and you are performing well. Whatever is required from the industry in that channel only, you are performing. That is very nice to see that your reports are reachable to that extent. Okay. So I want to just share you the marks that I have posted in GLearn. And I did not correct one or two students, like for roll number 8, Balkrishna roll number 8, and roll number 10, Niharika Reddy, and also Gayatri. Gayatri inko Gayatri, roll number 12. Roll number 12, Niharika, Niharika nuvena. You also did not submit. I checked mails also. Mails mail. That's why. And Balkrishna also is there. Balkrishna, why didn't you submit that day? Nuvena. Okay. Online huh? Now it is not possible. It is an exam. You cannot send now. I cannot do anything if you say now. And then you are losing marks unless who is roll number 1, Vivek.
Yes, sir.
What happened? You have not submitted.
So I don't have my laptop at that time, sir. I told you before only. I don't have my laptop with me that time, sir.
Okay, that day you told me, no, right?
Yes, sir.
But then I have given till time, no? You should have sent it the next day or next coming 2 days. You should have submitted.
Sir, yes, I tried, but I was
After
not able
getting
to arrange
laptop, you
that.
should have done it. You are unnecessarily you are losing marks. No, this is online procedure. This will be under the control of the dean. Directly they can access anytime and see, and there will not be any kind of you cannot change the marks because it is a proof over here. Okay, and who is roll number 5? Banu Prakash. Yeah, your report was good. I have gone through your report. I'll just show the report over here. Geetam Tech 2021 Banu Prakash, roll number 5. So you can see that this is what he has given. He has given what is the model first. He has given plan and elevation. That is what the basic idea is. And then how to create the grids is one screenshot he has taken. And then after taking the screenshot, how to give the materials. And he has taken a screenshot. Then section properties, column sizes and beam size, what are the sections that he has used. Has taken the screenshot of that. Then he has used the material over here and completed the geometry. But coming to the loadings, he has clearly mentioned over here what are the loadings. and the seismic loading. That so once you see this report, what it is clearly understandable, right? అర్థమవుతుంది కదా, ఫస్ట్ ఏం చేయాలి, సెకండ్ ఏంటి, థర్డ్ ఏంటి అంటే మనకు when we are doing some work, any work that which you are going to represent to the third person, it should be like this. Especially as a structural engineer, when I talk about detailing now, when I have drawn those diagrams in detailing, that detailing also has this. As a structural engineer, we have the software and we know the reinforcement, but the third person will not understand that. వాడికి ఇలా కాలమ్స్ చిన్న లైన్స్ లా ఉంటాయి, అవి ఎత్తులని అనుకుంటాడు, అండ్ 5400 mm is the steel that we got. He doesn't know how to, what is that and how to select the diameter. He doesn't even know that we have 8, 10, 12 dia, 11 dia ఉండదు, స్టాండర్డ్స్ ఉండవు, 13 dia, 14 dia ఉండదు, 15 dia ఉండదు, 16 dia ఉంటుంది మళ్ళీ. సో స్టాండర్డ్స్ కూడా తెలియవు. యాజ్ సివిల్ ఇంజనీర్స్ we will take that into considerations. So this is how you have to do the report work, and you also done the design work well. And it has link also he has provided over here. Good. And few of you have not submitted, so I am going to open that one. So directly you are going to, whatever might be your record work and all, you will lose 15 marks just for your thing. I'm just opening the access again. So you Balakrishna and Niharika and Gayatri and one more student who doesn't have the laptop, 4 of you please submit. 1, 2, 3, 4 of you submit the submit the report. Okay, I'm just extending the date now. I'm going to give till tomorrow 29. Okay, but tomorrow evening, maybe tomorrow night, you should upload the material, right? So you have submit the assignments regarding RCC structures with dead load, live load, and earthquake loading online. Interest and the A1 general questions, the general questions you have submitted. Now I am creating another assignment, that is design of RCC structure report. So to maximum extent, whatever you can do, you can do and submit by Feb 4th, 1 week I'm giving time. You can see whatever material is available online. Wherever you have doubt, you can go to the YouTube and you can see the videos, or you can see the video which I'm going to upload now for today's class to design the structure. Now you can do whatever you want, but try to give the best. That is what I'm always considered about. Offline ichana. This is also offline ఉంటుందండి. Design of concrete structure. Date I am giving till 4th, and it is an online submission. Okay, that's all for today. If you have any doubts, you can ask now. Yes, structural సంబంధించి submit report అంటే if you can take the report and upload, you can upload it. GitHub లో ఆప్షన్ ఉంటుంది, డైరెక్ట్ రిపోర్ట్ అని పడితే వచ్చేస్తుంది. అది కాకుండా మీ ఓన్ గా చేసింది మీ ఐడియాలజీ కోసం దాంట్లో అన్ని వచ్చేస్తాయి. సో ఐ డోంట్ వాంట్ దట్. యూ టేక్ అ స్క్రీన్ షాట్ అండ్ అప్లోడ్ ఇట్. Adi, that is what. If you can do it and you can upload, you are ready to do. Don't do for all. And annitki cheyaddu. One line of beams you do it. One line of beams, not even one beam. A row lo ok line beam ఉంటుంది కదా, దానికి చేయండి కంప్లీట్ గా ఒక beam కి. Okay, this is like ఇప్పుడు ఇక్కడ స్ట్రక్చర్ ఉందనుకోండి, if this is the beam over here and these are like partitions, some partitions ఉన్నాయి ఇక్కడ ఇలాగా, I mean other part side ఇలా ఉన్నాయి, one side ఇలా. So this part completely this is completely one beam, ఇదంతా ఒక beam. సో ఈ బీమ్ కి మీరు డిజైన్ చేస్తానంటే డీటెయిలింగ్ చేస్తానంటే దీనికి చేయాలి. అండ్ ఆల్సో ఫర్ వన్ కాలమ్, నో నీడ్ టు డూ ఫర్ ఆల్ ది కాలమ్స్. You can take one complete straight column for all the floors, not just one floor height. For all the floors, you can take one as one column, and you can give the reinforcement for that.
For joints and 5 beams in the divided. అలా డివైడ్ అవుతున్నప్పుడు ఒక్కొక్క దానికి ఒక్కొక్క reinforcement వస్తుంది. అలా 5 డిజైన్స్ ఉన్నాయన్నమాట. 5 beams.
ఇదంతా 1 2 3 4 5 కదా. This is completely one beam. మ్యాచ్ చేయాలి, అది మ్యాచ్ చేయాలి. Throughout will be same. Throughout will be same. If you take this beam, అంటే ఈ beam నేను ఇప్పుడు డ్రా చేస్తాను చూడండి. If I draw this beam now, this like this is my length throughout the length. I am drawing the 3D view like this, and this is the beam. Let us think that this is the beam throughout, right? This is the beam. Okay, so ఇక్కడ ఏంటంటే అదర్ డైరెక్షన్ లో ఇలా అటాచ్ అయ్యి ఉన్నాయి కదా, ఈ అదర్ డైరెక్షన్ లో దిస్ in this direction there is one beam, there is another beam over here, and there is another beam over here which is going into the other direction, and there is another beam going like this. So this is actually completely one beam only. So you have to give 3 or 2 rods which will pass common to all the beams. Then at every joint, based on the reinforcement difference, 2 bars, 3 bars extra, 2 bars extra, 3 bars extra, 4 bars extra. The different reinforcement is there. No difference ఉంటుంది కదా, central reinforcement తీసేగా difference reinforcement ఉంటుంది కదా, దానికి 1 bar extra, 2 bars extra, 3 bars extra అని మీరు ఇవ్వచ్చు మాట. That is called, I'll show you one detailing diagram also. Just see, I'll show you one model so that you will understand. So this is the floor. This is actually the floor plan. This is actually the floor plan. And we have lift over here and the rest of the thing. So for this one, side of this, you can see one more diagram with white lines. You can see there. White lines unnayi chusara. Those are the beam layout. That is the beam layout. Okay. That white lines I have separated and I have drawn it over here. These are the beams. These are the actual beams that are coming in that particular floor. And these beams are called as typical beam layout. Only the beam layout will be there to understand where the beams are coming to the client. And then the detailing part. So this is how you can give the detailing part. For the horizontal direction, this is the reinforcement. Horizontal direction, you can see the grid one is there now. In that direction, this is the reinforcement. Okay. Then you have only two spans of you, three spans only. This will not help you. This beam you see, the I think I have not done that detailing. That detailing is not there in this floor plan. This is actually the complete beam. What I'm trying to say is that it's a grid A on the student grid A. This A. You can see grid A, B, C. So this A, you can see that there is beam continuously going on. Sorry, there's a break over here. Yeah, grid A, not grid A, grid B. See grid B from here, grid 8, from 8 to grid 1, there is a continuous beam. That is called as continuous beam. So that is completely one beam. For that beam, you have to give the detailing. How to give? How to give that? I'll show from another project. That is. Footing. Yeah, this is one direction. Now see this side you have, you see grid G. Grid G is there now. There is a beam continuously going on, and you can see the reinforcement. Top reinforcement I have given 216 and plus 116 extra. And at the bottom 216 I have given, and again this side I have given for this span I have given again 216 and 216 and 116. So it is coming uniform. The reinforcement is almost like same, so the reinforcement does not change much of here. You can see the other direction. This is the other direction. You can see this grid 1. The grid 1, you can see the beam continuing like this. You can see commonly I have given 216. You can see that commonly there is 216. So that beam is continuously going on. And I have given 112. See, the 112 is there below that. That is the extra rod. But at the bottom, you see that at the bottom, you can see I have given 212 and 212 extra. That means 212 are going continuously. 212 are going continuously and 212 extra I have given, depending upon the bending of the span. Here I have given only 112. You can see that I have given 112. Like that it will vary, it will change. Okay. Okay, please don't go in depth. You might get confused a lot. You just do the designing part. If it is not possible, you just do it. But the basic part you are reaching, that is what I have observed. As per the report that you have submitted in mid-1, I am little bit satisfied with that. Make sure that you practice in this manner only. It will be advantage for you. Fine. So with this, I am going to stop the session over here. So anyone, any student from online, has any doubt, you can ask.